For our lesson today, radical expressions, they have a lot to do with perfect squares. Radical expressions and exponents go hand in hand because they're opposites of each other. And you're about to see why here when we list the first 12 perfect squares. There's not only 12 perfect squares, there are several perfect squares. But we have to know perfect squares in order to be successful with radical expressions, because today you're going to be given radical expressions that are not perfect squares, where you have to figure out what perfect square times another is going to give us the number inside of our radical expression. For the first 12 perfect squares, the way that I like to remember it is what number times another number gives me the perfect square. For instance, 1 times 1 equals 1. And I can also write it as 1 squared. So 1 is considered a perfect square. Okay. Another perfect square would be 2 times 2, which equals 4. And I can also write it as 2 squared. So 4 is a perfect square. If we keep going with this trend, the next one would be 3 times 3, which equals 9. I can also write it as 3 squared, so 9 is a perfect square. The numbers have to be the same, and if you can take that number and multiply it by itself, it gives us our perfect square. We keep going, 4 times 4 equals 16, and I can also write it as 4 squared, so 16 is a perfect square. And I want to see you guys continue. I want to see you guys write the next perfect squares all the way up until you get to 12 times 12, which equals 144. And I can also write it as 12 squared. 144 is a perfect square. And we need to keep these fresh in our mind because we need to use these today to be successful on simplifying radical expressions.